And welcome back. This video is on anti-differentiation using partial fractions. And what partial fractions are is, I guess it's the opposite of simplifying, where in algebra when you've got something like this, 3 over x minus 1 or something like that, to put those together you put them over the same denominator. Okay, and then you go, 1 times x minus 1 type thing plus 3 over, oh gee, it's not working up there, x plus 2, that sort of thing. Usually we'd be going in that direction, but what partial fractions does is, what we're going to do is go in this direction. In other words, if you've got a quadratic on the bottom line that can be factored into linear factors, you can break that up into two different partial fractions, one that looks like that and one that looks like that, one that has that linear factor and one that has that linear factor there. Okay, so that's what we're doing, and the reason we do it is because we can't integrate this, but we can integrate this. And so again, like in most differentiation, what we're trying to do is just change the form, change what it looks like, so we get it to something that we can anti-differentiate. And so basically what you have, if you have some linear over some quadratic down the bottom, x plus a, x plus b, something like that, what you write, you make that equivalent to a over x plus a, I chose bad letters here, and x plus b, something like that. Okay, so you write it over like that, you put it together, and then you figure out what is a, what is b. Once you have it in that form, you can easily anti-differentiate, and I'll show you in the examples. Just two special cases to be aware of. If you have a higher power on the top line, x minus 1, x squared minus 1 or something like that, if you've got a greater power on the top line, so your degree is higher top than the bottom, then first you need to use long division. Okay, if you use long division on that, then what you get is a lower power on the top line, and then which will probably be either a constant or a linear term, and then you can apply partial fractions to that. Okay, so that's your first problem case, and so that's the first one. The second case is when you've got something linear over something squared, so x plus a squared, okay, something like that. What you write that is a over x plus little a plus b over x plus a squared, like that. So that's how you need to write that. And if you try to do this with just x plus a and x plus a, you'll see that it doesn't work. And so you need to do it in those fractions. So they're the two special cases. Let's get on to some quick examples of how to do this. Okay, so firstly, let's just do it. So I'll do, wife's cooking up something or other. So 2x plus 3 over x plus 1, x minus 2. Let's find the antiderivative of this. So you can see we don't know how to antiderive this. Okay, so what we need to do first is some manipulation. So let's do this. So here we're going to get 2x plus 3 over x plus 1, x minus 2. We're going to write that as being equivalent to sum a over x plus 1 plus sum b over x minus 2. And so we write it like that, and we want to figure out what is a and what's b. So now we'll put those together. So that's equal to x plus 1, x minus 2. And on the top line it's going to be a times x minus 2 plus b x plus 1 when we put those together. And so that's ax minus 2a plus bx plus b over that bottom line, x plus 1, x minus 2. Okay, so at this stage we're looking okay. What we know now is that this here must be equal to this, because we have the same bottom line and they're equal, so therefore we must have the same top line. And so what that means is that we can equate coefficients here. We can equate coefficients. Equate our coefficients. And so let's have a look at that. So the coefficient of x in this, so the coefficient of x over here is 2, so 2 equals, what's the coefficient of x over here? Well, it's a plus b, so a plus b. There we go. And what's the constant term there is 3. What's the constant term over here? It's negative 2a plus b. Negative 2a plus b. And so what you end up with is simultaneous equations here that we just need to solve. So let's have a look at this. If we subtract these from each other, we get 2 minus 3, which is negative 1, equals a minus 2a equals 3a. So therefore, a is equal to negative 1/3. And just make sure I got that right. 2 minus 1, a minus negative 2a. Yep, fantastic. And so therefore, b is equal to 2 minus a. So 2, let's write it down. 2 minus 1/3. 2 minus negative 1/3 equals 2 and 1/3, which is 6 7/3. Okay, so there's your two values. There's a and there's b. So now we know those, we can do the anti-differentiation. So therefore, the integral of 2x plus 3, I'll try not to run out of room. These do take a bit of space. Always allow yourself a bit of space to do these. They do hurt you a little bit. Is equal to, let's split this up now, okay? So it's equal to a over x plus 1. So a is negative 1/3, so negative 1/3 over x plus 1 plus b 7/3 over x minus 2 dx, okay? And we can anti-different, I could write this as negative 1/3 on the bottom line, but there's actually no need to do that in this case, and you'll see why. This is equal to, we can now anti-differentiate this. This negative 1/3 just hangs out the front, negative 1/3. And the anti-differential of 1 over x plus 1 is log base e x plus 1, like that. And this here is plus 7/3 log e x minus 2 plus c. Now that is your answer. It can be simplified somewhat by taking, I could take a third out the front and different powers. I've just run out of space here, but I'll show you this in class. And so, yeah, I've just run out of space. I'm not going to have enough space to clean this up. But what you do, oh, look, I'm going to do it in one. That's equal to, we'll take negative 1/3 out the front, and then you'll have in the brackets log e x plus 1 plus 7 log e x minus 2. Just have that in brackets. Now this 7 could go up here as a power of 7 using your log laws, so that 7 disappears, plus c. And so what that's equal to is 1/3 log e, and what we're going to have, because you go into powers, on the top line, they're both going to be negative, and so I think I'll just reassess here. So I'll leave that negative 1/3 out because it just becomes annoying. And when you add two logs together, you just multiply the expression. So log e x plus 1 times x minus 2 to the power 7 plus c. And there you go. Okay, so there's one. I think I've got enough time just to do a squared one, and I do. So let me do one more. Let's do another example. This time, one of the squared ones. So let's just say 3 over x plus, oh no, it has to be x. 3x minus 4, x plus 2 squared. Okay, dx. Let's do it. So I told you before that in this case, what we need to do, and I'll change colours, is we've got 3x minus 4 over x plus 2 squared. That's equal to a, or equivalent to a over x plus 2 plus b over x plus 2 squared. Okay, so let's do this now. What this is equivalent to is something over x plus 2 squared. what do we need to do that? We need to times that by x plus 2, so you're going to get a x plus 2a, and that b is just going to stay the same. So what have we got? What do we end up with? We end up with, therefore, coefficient of x is 3. What's the coefficient of x over here? We get a. Coefficient of, well, the constant is -4. Over here, we've got 2a plus b. So therefore, what's b equal to? Well, b is equal to -4 minus 2a, so that's -4 minus 6. -4 minus 6 is minus 10. And so there's our a and b. And so let's go back to our integral. So therefore, integral 3x minus 4 over x plus 2 squared is dx, almost forgot it, is equal to a over x plus 2, so 3 over x plus 2, and I've got the integral, oh, that was loud, plus -10 over x plus 2 squared dx. I get that right, plus b -10 over x plus 2 squared. Now we can integrate this. Okay, fantastic. So here we go. So it's at a point now where we can integrate. So this here is 3 log e x plus 2. Fantastic. If you want just to, if this looks strange to you, think about it as 3 over x plus 2 minus 10 x plus 2 to the -2. And remember, we know how to integrate linear terms to a power. Okay, we know how to do this one. So looking at that, so that's minus 10 x plus 2. We increase the power by 1, so that goes to -1, and then we divide by -1, so that'll go to a plus, and then we divide by the a term, whatever's in front of the x, which is just a 1 in this case. So there's your answer there, plus c. And that's basically it. I'll just clean it up a little. Oops, just totally messed that up. Just wrote another line there, x plus 2 plus 10 over x plus 2 plus c. And there you go, and there's the answer there. So that actually, those ones tend to be a little bit easier because the simultaneous equations are easier and the numbers are easier. So there you go. So that's partial fractions. They're good fun. They take a while. There you go.